A tsunami has struck the island nation of Tonga, sending shockwaves, both literal and metaphorical, across the globe. Satellite images capture the sheer scale of this disaster, and a tsunami advisory is now in effect for the entire U.S. West Coast and Alaska. This catastrophic event is tied to a colossal underwater volcanic eruption near the Challenger Deep, the deepest point of the Mariana Trench. Hidden beneath the ocean's surface, this eruption unleashed seismic ripples that register worldwide, marking it as one of the most extraordinary geological phenomena of our time. The Mariana Trench, located in the western Pacific Ocean, is a geological marvel. It spans over 1,500 miles in length and plunges nearly 36,000 feet at its deepest point, the Challenger Deep. The immense pressures in this region are so extreme that they could crush a human instantly without specialized equipment. This remote and enigmatic location, long shrouded in mystery, is now the site of an unparalleled display of the Earth's raw power. Scientists who have long studied the trench for its hydrothermal vents, unique ecosystems, and unusual geological formations were unprepared for the scale and intensity of this eruption. The eruption began with a series of deep-sea earthquakes detected by instruments placed on the Pacific Ocean floor. At first, scientists assumed it was routine tectonic activity, as the trench lies at the boundary of the Pacific Plate and the Philippine Sea Plate, where constant grinding and shifting cause earthquakes and occasional volcanic activity. However, the seismic waves intensified over several hours, suggesting something far larger was unfolding. Oceanographic stations detected rapid changes in water temperature and chemical composition, signaling that magma was on the move. The inevitable eruption finally occurred over 20,000 feet below the surface, releasing torrents of molten magma, superheated gases, and ash into the ocean. The force of the explosion sent shockwaves across the Pacific, with plumes of material rising miles into the water column. The eruption has shocked geologists due to its unprecedented scale and its proximity to the Challenger Deep. Submarine eruptions are notoriously difficult to study because they occur in remote and inaccessible locations, but this event has provided rare insight into the Earth's dynamic processes. The eruption created a massive underwater cloud of ash and debris, with the intense heat causing surrounding seawater to boil and vaporize. This phenomenon, known as the submarine volcanic explosion, released vast amounts of energy and shock waves that travel for hundreds of miles. Satellite images and sonar scans have revealed a new landmass, a proto-island, rising from the ocean floor, potentially joining the ranks of volcanic islands like Iceland and Hawaii. Beyond its geological significance, the eruption has had profound ecological impacts. The Mariana Trench hosts some of the most extreme and unique ecosystems on Earth, where life thrives in complete darkness and under immense pressure. The eruption disrupted these delicate ecosystems, burying hydrothermal vent communities under layers of ash and debris. While some species may face extinction, others may adapt to the new environment, and the cooling magma could eventually form volcanic rock that serves as a substrate for marine life. This cycle of destruction and renewal highlights the resilience of life and the dynamic nature of our planet. The event also raises concerns about broader environmental and societal impacts. The release of gases such as carbon dioxide, sulfur dioxide, and methane has altered the ocean's water chemistry, potentially affecting marine ecosystems and the food chains that millions rely on. Acidification could harm coral reefs and shell-forming organisms, with cascading effects on fisheries. Additionally, the eruption's proximity to steep underwater slopes has heightened fears of undersea landslides, which could generate destructive tsunamis. Coastal communities in the Pacific Rim remain on high alert as emergency management agencies monitor the situation. In response to the eruption, a multinational scientific effort has been launched to study its aftermath. Research vessels equipped with advanced technology, such as remotely operated vehicles and autonomous underwater drones, have been dispatched to the area. These tools allow scientists to collect samples, map the seafloor, and monitor ongoing activity. Early data reveal that the magma is unusually rich in rare earth elements, sparking interest from industries relying on these materials for technologies like smartphones, electric vehicles, and renewable energy systems. However, this discovery also raises ethical and environmental concerns, as deep-sea mining could devastate marine ecosystems. This extraordinary event has also provided valuable insights into the deep Earth processes that drive volcanic activity. By analyzing the magma's chemical composition, scientists can better understand the materials and conditions within the Earth's mantle, furthering our knowledge of plate tectonics and volcanism. The eruption near the Challenger Deep underscores the planet's incredible power and complexity, serving as a reminder of humanity's vulnerability to natural forces far beyond our control. It also highlights the importance of studying and respecting these forces to better prepare for and mitigate their impacts. As the world watches this geological drama unfold, it becomes clear that Earth is a living, ever-changing planet, and our relationship with nature must adapt accordingly. The underwater volcanic eruption near the Challenger Deep has provided remarkable insights into Earth's systems, illustrating the intricate and dynamic forces that shape our planet. This event is more than a geological curiosity. It's a vivid reminder of how humanity and nature are interconnected. As scientists delve deeper into this phenomenon, they are uncovering a story that not only expands our understanding of the natural world, but also forces us to confront the challenges of living on a volatile and ever-changing planet. The eruption serves as a wake-up call, urging us to explore how we can coexist with the Earth while respecting its raw power and unpredictability. The eruption has opened an entirely new chapter in the ongoing story of our planet, a narrative still being written. Whether this chapter unfolds as a tale of triumph, tragedy, or transformation is yet to be seen, but one thing is clear. This eruption is a pivotal moment. It underscores the need for humanity to better understand the Earth's processes, especially as they become increasingly critical for our survival. This event is not just a scientific phenomenon. It is a global moment of reckoning, forcing scientists, governments, and communities to grapple with questions about exploration, conservation, disaster preparedness, and sustainable living. These discussions will shape the future of our relationship with the Earth and our ability to adapt to its ever-changing landscape. The Challenger Deep lies within the Mariana Trench, the deepest point on Earth and part of the Pacific Ring of Fire, a region that is home to 75% of the world's active and dormant volcanoes and 90% of its earthquakes. The Ring of Fire is a massive horseshoe-shaped zone of tectonic plate boundaries encircling the Pacific Ocean, where plates constantly collide, pull apart, and slide past one another, generating immense geological stress. Even within this volatile region, the Mariana Trench is uniquely extraordinary. It is the product of a process called subduction, where the Pacific Plate is forced beneath the smaller Philippine Sea Plate. This action generates magma deep within the mantle, which rises to create volcanic features over millions of years. The eruption near the Challenger Deep has further transformed this underwater landscape, adding another layer of complexity to this already dynamic region. The eruption stands out for its location and magnitude, taking place in one of the most remote and extreme environments on Earth, near the Challenger Deep. The event has unfolded in a place where the pressure is over 1,000 times greater than at sea level, an environment so hostile that it has been visited by only a handful of people. Despite these conditions, the eruption has managed to disrupt the seafloor and potentially the entire Pacific Ocean. The sheer scale of this event is staggering. Initial estimates suggest that the volume of magma release rivals some of the largest submarine eruptions in recorded history. This has led to the rapid formation of a massive volcanic edifice on the ocean floor, with lava flows spreading outward to create a new volcanic ridge. If the eruption continues, it could eventually form a new island, much like Iceland's Surtsey Island in 1963 or the Hawaiian Islands, which emerged over millions of years due to volcanic activity. Witnessing such a process in real time would provide scientists with an unprecedented opportunity to study the birth of a volcanic island. However, the implications of the eruption extend far beyond its geological significance. The release of volcanic gases, such as carbon dioxide and sulfur dioxide into the ocean, is altering its chemical composition, creating ripple effects throughout marine ecosystems. Deep-sea hydrothermal vent communities, which are already adapted to extreme conditions, now face additional stressors. Some species may thrive in this newly altered environment, while others may struggle to survive. The ash and debris from the eruption are spreading across the ocean floor, burying habitats and disrupting food chains. Simultaneously, the release of nutrients from the volcanic material is fueling algal blooms in the overlying waters. While these blooms can temporarily boost productivity, they may also lead to oxygen depletion, creating dead zones where marine life cannot survive. The long-term ecological impacts of these changes remain uncertain but could be profound. One of the most pressing concerns is the potential for a tsunami. While submarine eruptions typically do not generate tsunamis directly, the possibility of underwater landslides or the collapse of the volcanic structure poses a serious risk. If large volumes of material were to shift suddenly, the displaced water could create waves capable of traveling vast distances. Coastal communities around the Pacific Rim are on high alert, with monitoring systems closely observing for any unusual activity. In addition to the immediate risks, the eruption has far-reaching implications for global systems. The release of volcanic gases and particles into the ocean and atmosphere has the potential to influence weather patterns, ocean currents, and even the global carbon cycle. Submarine eruptions are a natural part of Earth's processes, but their effects can interact with human activities, such as industrial emissions and overfishing, to create complex environmental challenges. The eruption serves as a stark reminder of how closely linked humanity is to the natural world and the importance of understanding these interactions. Despite the challenges, the eruption offers an extraordinary scientific opportunity. Researchers are using advanced technologies, such as remotely operated vehicles, ROVs, and autonomous underwater drones, to study the event in real time. These tools are capturing high-resolution images and videos of the eruption site, allowing scientists to analyze its dynamics and effects on the seafloor. The data being collected is invaluable for understanding not just this eruption, but also the broader processes of underwater volcanism. By studying the composition of the magma, scientists can gain insights into conditions in Earth's mantle and the role of subduction zones in generating volcanic activity. This knowledge is crucial for understanding the long-term evolution of our planet and its capacity to support life. The eruption has also sparked renewed interest in deep-sea exploration. The Challenger Deep and the surrounding Mariana Trench remain some of the least explored places on Earth, despite their significance for understanding geology, biology, and climate. However, this renewed interest comes with ethical and environmental challenges. The discovery of rare earth elements and other valuable materials in volcanic deposits has drawn attention from the mining industry. While deep-sea mining has the potential to provide resources for renewable energy and advanced technologies, it also poses significant risks to marine ecosystems. Balancing the benefits of resource extraction with the need for conservation will be a critical challenge in the years to come. Beyond its scientific and environmental implications, the eruption has ignited a broader conversation about humanity's relationship with nature. It serves as a powerful reminder of Earth's immense power and unpredictability, challenging us to think about how we can coexist with a planet that is constantly changing. The event inspires awe and curiosity, reminding us of the mysteries that lie beneath the ocean's surface and the need for continued investment in oceanographic research. It is also a call to action for scientists, policymakers, and the public to work together to understand and protect our world. The eruption near the Challenger Deep is not just a geological event. It is a story of transformation, resilience, and discovery. It is a testament to the dynamic nature of our planet and the incredible forces that shape it. As scientists continue to study this event and its aftermath, we are reminded of the importance of curiosity, collaboration, and stewardship in our quest to understand Earth and our place within it. This is a moment of awe and inspiration, a reminder that even in the deepest, most remote parts of the ocean, far from human eyes, The Earth is alive with activity. The story of this eruption is still unfolding, and its lessons will resonate for generations to come. It challenges us to think not only about the mysteries of our planet, but also about our responsibility to explore, understand, and protect the world we share.